Today's session is devoted to probability. What we'll do is we'll do a brief recap of what probability is, and then we'll look at how we can calculate probabilities, and we'll take up some examples so as to illustrate the concept of or to explain the concept of probability. Now, why is probability important? One of the important reasons is that we use a lot of probability in inferential statistics. We use probability in the areas of hypothesis testing. We use probability in the areas of decision making under uncertainty. So probability has a huge application in the business and management discipline, academic research, quality control, testing. Probability has a huge implication in these areas and huge application as well. So the classic example is of a flipping a coin. So when we flip a coin, we ask the question, will we get a head or will we get a tail? So there are only two possible outcomes, either a head or a tail. And the probability of getting a head is 50%, or the chance is 50%, and the probability for getting a tail is 50%. But there could be situations when you don't have a probability of an outcome. So the probability will be considered as zero. So in certain situations, the probability could be 1. And most of the time, the probability is going to lie in between. So as you can see from this probability line, so 0 is basically the probability for an impossible event, something which can never happen. And 1 is the probability for a certain event. Probability is half for an even chance. Okay, so when you have a 50-50, so in the case of a coin flip, we say that the probability is for an even chance. You can have a coin, you can get a head. When you flip a coin, you can get a head, you can get a tail. So this is a simple example of probability. Now we could take this example, we could extend it to, let's say, the roll of a dice. So when we throw a dice or when we roll a dice, what are the possible outcomes? We can get a 1, we can get a 2, we can get a 3, 4, 5, or a 6. So there's 6 possible outcomes and each outcome has an equal chance. So if we say what is the probability of getting a 1? So the probability of getting a 1 is 1 by 6. What is the probability of getting a 2? What is the probability of getting a 2? It is again 1 by 6. Now if somebody were to say what is the probability of getting a 0? So the probability of getting a 0 is 0 because that's an impossible event. If somebody says what is the probability of getting a 7? So the probability of getting a 7 is 0. Okay, if somebody asks you what is the probability of getting any one of these numbers, 1, 2, 3, 4, 5, 6, so you will say 1. Why? Because that's certain. Because when you roll a dice, you will either get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. So that means it's a certain event. So that is how we need to understand probability. And this is again depicted in different ways. So impossible is when you have a 0 probability of an event, and unlikely, we say it's around 25%. We say as likely as not, that means it's an even chance. It may happen, it may not happen. So that's 50-50% probability. And likely when we have somewhere around 75% of the chance, and certain when we have 100% chance. So we use probability. We talk of chances in real life. Like example, somebody may be terminally ill, he or she goes to a doctor and the doctor says, you have a chance, you have 75% chances of surviving. And probably the doctor may be pessimistic, and if your disease is advanced, the doctor may say you have, uh, 25% chances of surviving. So that means that the probability is unlikely. So you have 25% of chances, but it is towards, you are more likely to die as compared to a 75% probability where you are more likely to survive. So that is how, probability, is understood in the context of medical sciences, for example. So what do we have? We have experiments, and there are possible outcomes of those experiments. And we have already discussed these concepts before. For example, if we roll a dice, the possible outcomes are 1, 2, 3, 4, 5, and 6. And the sample space is again total number of possible outcomes, 1, 2, 3, 4, 5, 6. Now, one concept that we all know in probability is that there is something called as theoretical probability. Like for example, flipping a coin, we can get a head, we can get a tail. But in real life, what happens in real life may be completely different or maybe not exactly the same. So when we say the theoretical probability of getting a head or getting a tail is 50-50%, experimental probability could be slightly different. It could be 45% heads. Like for example, you flip a coin 100 times, you may get 45% heads and you may get 55% tails, or vice versa. So this is the concept of experimental probability. So a lot of time we base our conclusions on experimental probability, but always remember there's a caveat. The caveat is that if we were to flip the coin many times, a large number of times, you know, probably 10,000, 20,000, 30,000, 50,000 times, and we were to note down the results, it would approximate 50% heads and it would approximate 50% tails. Even if there is a difference, the difference will be very small. So without flipping the coin 30,000 times or 40,000 times or 1 million times, we can actually predict, the mathematical probability also. So always keep this in mind. Experimental probability is what happens when we try it out, and theoretical probability is what we expect to happen. So in the case of the dice, what is the theoretical probability? The theoretical probability of any one of the numbers from 1 to 6 is 1 by 6. But when we throw the dice, this could be different, and if we were to note it down, this result could be different. For example, you know we rolled the dice 500 times and we noted how it fell each of the time. So the first, we saw that 96 times we got a 1, 87 times 87 times we got a 2, 70 times we got a 3, 94 times we got a 4, 75 times we got a 5, and 79 times we got a 6. So based on this we can calculate the experimental probability. Now if you look at the question, one of the questions says that what is the probability that we got a 4? So the probability of getting a 4 was 94 times we got a 4 out of 500. So the probability of getting a 4 is 94 divided by 500, and we'll get the probability. So probability calculations are very simple. You don't need Excel templates, or you don't need to do it on Excel unless and until you are not, or you don't need to use even a calculator unless and until you are not very comfortable doing small fractions. And then probably I would say that you could use a calculator, or you could use even Excel if you want to be absolutely sure, if you are concerned about your calculations. Otherwise, it's no rocket science. It's a very simple, division and multiplication and addition. That's all there is in probability. Similarly, if somebody were to ask you a question, what is the result that the number that was obtained was actually an odd number? So we all know that in real life, what is the theoretical probability? What is the theoretical probability in a dice? There are three odd numbers and there are three even numbers. So what is the probability of getting an odd number? It is 3 by 6, which is half. And what is the probability of getting an even number? It is again half, 3 by 6. But here, if we talk of rolling an odd number, so 96 times we got a 1. So 96, then 3 is odd number, 96 plus 70 plus 75. We sum this up, divided by the total number of times the die was rolled, we get the empirical probability. So here you can see it is, we just add these up and we divide it by 500, we get the probability of getting an odd number. Now since odd and even are, if the probability is 1 minus, so we will just if we don't have to calculate the probability, we don't have to add the odd numbers, we just subtract the probability of the odd numbers from 1, we'll get it for the even number, the probability of getting an even number. So that's how it can also be done. So these are some of the terminologies which are involved. A random experiment. So we have an experiment and that experiment is random. Random in the sense that when we flip the coin or we throw the dice, we don't know the outcome. So the outcome is random. You could get a head, you could get a tail, you could get a 1, you could get a 2, you could get a 3. We don't know the outcome. So the outcome is random. So these are some examples. One is flipping the coin. For example, the second example is we can see We have a bag which is full of colored marble balls. We have white, we have red, we have green. And when you select one of the balls, you are doing it out of random and you are predicting the probability. So for example, in this case, we have one white ball, one red ball, and two green marbles, okay? Or marbles are obviously small balls. So basically there are four. So if somebody asks you what is the probability of getting a white, so the white is one. And how many are there? We have four balls. So what will be the probability? The probability will be 1 divided by 4. That will be the probability of white. If somebody asks you what is the probability of red, you will say 1 divided by 4. That is for red. And what is the probability for 2? Because green are more in number, that is, they're 2 in number. So 2 divided by 4 is again half. Now, the third one is slightly different. Here we are saying roll 2 dice and observe the sum of the points on each of the top faces of each die. Now what is happening here is, here we are rolling 2 dice, okay, and each dice has numbers 1 to 6 which are independent of the numbers on the other dice. So if you have a 1 on this, you could have 1 on that, or you could have 2 on that, you could have 3 on that, you could have 4 on that, 5 on that, and 6 on that. So you can have multiple, combinations. So all these are called as experiments. Taking out a ball from the bag is an experiment. Throwing 2 dice is an experiment. Flipping a coin is an experiment. So note this down in your mind that these are all experiments. Now, one of the classic examples is about a deck of cards. So a deck of cards contains 52 cards, and each 52 cards, you have certain divisions. You have king, queen, and you have the numbered cards, and you have the jack, and you have the aces. Then you have the colored cards. Okay, so you have the red colored cards and you have the black colored cards. So they are half a number. So same ways you can calculate the probability. So if you want to calculate the probability of getting a club, so there are 13 clubs. So 13 by 52 is 1 by 4. If we have to calculate the probability of getting spades, so what is the probability of getting a spade? So the probability of getting one spade is actually 13 by 52, because there are 13 spade cards. But if somebody were to ask you what is the probability of getting a king, so there are only 4 kings out of 52 cards, so that means 4 by 52. If somebody asks you what is the probability of getting, a red king, so there are 2 red kings now, not 4, so 2 by 52, so that is 1 by 26. That's the probability. Now, many people are confused between what is a simple event and what is a compound event. Now, simple event is what we were just talking of. What is the probability of getting one king is a simple event. Okay. So we say that what is the probability of getting one king? So what the probability of getting one king is one, you just compute the probability like we have been doing. Or what is the probability of getting, uh, a spade? So we compute the probability like we have been doing. We know there are 13 cards of a spade, 13 by 52. So we compute the probability of that. What is the probability of getting a king? So there are 4 kings, so 4 by 52. So that is the probability of getting a king. Now, when we say what is the probability of getting 2 kings? So now that becomes a compound event, because here what happens? You have 2 kings now. We are talking of 2 kings. So the probability of 1 king and 2 kings is different. We are talking of getting 2 kings. So when we talk of 2, it becomes a compound probability. So if you look at this example, it says a simple event, the selected card is 2 of the clubs. That is, we are selecting 2 of a club. So there is only one 2 of a club in a pack of, yes, there are only one 2 of a club in the pack of 52 cards. So the probability is 1 by 52. But the probability of selecting a king is, there are 4 kings, so that means 4 by 52. So you divide 4 by 52 and you will get the probability of getting a king. The probability of getting 2 kings, that means now you want the probability of getting 2 kings. Now that is going to be a different game altogether, because you want one king and you want another king. So this means a king and a king. So in this situation we apply something called as a rule of product. That means If we want a king and a king, we'll multiply the probabilities. So the first is the king and the second is the king. So 1 by 4 by 52 multiplied by 452. That is the probability of getting two kings. So this is how probability works. Now let us look at this example. Let us look at a very minuscule example. Let us not talk of 52 cards. Let's assume that we now, instead of one coin, we are flipping two coins. And let's look at the first coin. So if we flip a coin, what is the probability of getting a head? We have the probability of getting the head is, the probability of getting a head is actually half. So you can see the probability of getting a head is half. Similarly, what is the probability of getting a tail? The probability of getting a tail is again half. Now, this is the first coin. When we flip the other coin, what can happen? We already have a head here. So what can happen with the other coin? You can get a head or you can get a tail. These are the two things which can happen with the second coin. Similarly, if we had in the first toss, we had got the tail. So what could possibly happen with the next toss, with the next coin? We get a head or we get a tail. So these are the four possible outcomes: head, 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 tail, head, and tail, tail. So if we talk of a head and another head, so the probability, as you can see, is multiplied. The probability is multiplied. Half into half, it becomes 1 by 4. Similarly, the probability of head and tail, half into half, because each of them have a probability of half. So that is why half and half, this becomes 1 by 4. Same is the case with tail and head, half and half, 1 by 4, and 1 by 2 into 1 by 2. And if you were to add all these up to total probability, you can see I always say that the total probability will always be 1. So 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4, the sum of all the probabilities is 1. So this example is just an example for beginners. This can be expanded in different ways, different forms. So for example, if somebody asks you, what is the probability of not getting a head? So what will you say? What is the probability of not getting a head? When you look at this, you can see you have a head here, you have a head here, you have a head here, but you don't have a head here. So you will say that the probability of not getting a head is 1 by 4. Similarly, if somebody says, what is the probability of not getting any tail? So you will say, this is the one which does not contain any tail. The probability is 1 by 4. If somebody asks you, what is the probability of getting at least one head? So what happens? This is one head. There are two heads. So at least means it can be more than two. So this will qualify. This will qualify. This will qualify. So 1 by 4 plus 1 by 4 and 1 by 4. So you add these probabilities. This becomes 3 by 4. And this is, you don't have any head here. So what happens? You have 75% probability when you flip the coin. You have 75% probability that you might get a head. Similarly, you have 75% probability that you might get a tail. But getting two heads, the probability is unlikely, that is 25%. For getting a tail, the probability is unlikely, that is 25%. Two tails is unlikely. Now let's move on. We look at an example of rolling two dice. We're looking at two dice. Now we are not talking of one, we are talking of two dice. Now in a dice, the outcomes are 6. So that means if you roll two dice, it's going to be complicated because you will have a lot of combinations. So let's look at it. These are the combinations. So let's say that this is one dice and this is another one. So when we roll when we roll the first dice, we get a 1. We roll the second dice, we get a 1. And what is the sum of these two? The sum of these two dice is again 2. The same thing happens. We roll the first dice is 1, the second dice we get a 2, and the sum is 3, and so on and so forth. So you can see these are the sum, okay, and they have been listed like this: 1 1 1 2 1 3 1 4 1 5 1 6. Okay. Now in the second case, let's look at another scenario. We roll the dice, we can get a 2 on the first dice, and then we can get all these combinations in the second dice. So we roll a 2 and the second dice rolls a 1. This we again, it again rolls a 2, it again rolls a 3, it again rolls a 4, it again rolls a 5, and it again rolls a 6. So we have listed all the possible sums. Same thing we keep on repeating until each and every combination has been exhausted. So there could be a combination of 1 1, there could be a combination of 1 2, 1 3, 1 4, 1 5, 1 6, 2 1, and so on and so forth. So what we get is these are the possible sums that we could actually get by rolling 2 dice. Okay. Now, if somebody were to ask you, what are the total number of outcomes? What are the all possible outcomes here? These are 36. Okay. 6 into 6 is 36. So these are 36 outcomes. If somebody were to ask you, and each of these outcome, the probability is 1 by 36. So for getting a 2, the probability is 1 by 36. For get, have a look at this. Okay. So let's go back. I think let's talk of the calculation of the probabilities. So you get 2 only once in 36. So the probability of getting a 2 is 2 by 36. You get 3 only twice in 36. So what is the probability? 2 by 36. So this is 1 by 36, this is 2 by 36. This is 3 by 36 because you get 4 3 times. This is 4 by 36. This is 5 by 36. And this is 6 by 36. And this is 7 by 36. And this is, sorry, this is 5 by 36, and this is 4 by 36, and this is 3 by 36, and this is 2 by 36, and this is 1 by 36. So the probability of getting a 12, a sum of 12, is very small. The probability of getting a sum of 2 is very small. So these are very unlikely events. So which event is most likely? The one which is repeating, which you can see, visually examine, and you can see the one which is repeating the most. So 7, the occurrence of 7 is 1 2 3 4 5 6 times. So the getting a 7 has the highest probability. Now if somebody were to ask you that what is the probability of not getting a 7, so that would mean you just compute the probability of getting a 7, which is 1 by 36, 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 1 by 36. That essentially means it is 6 by 36. And 6 by 36 is 1 by 6. So 1 by 6 is the probability of getting a 7. So if we subtract this from 1, we get the probability of not getting a 7. So this is pretty simple. Similarly, what is the probability of getting an 8 and what is the probability of not getting an 8? So you calculate one probability and you subtract it from the other. Okay, so this is called as the rule of complement. We have seen this in numerous times, in previous examples. So always understand this. I think this is something which some of the students were not able to understand. So that is the reason why I actually searched for an image which could actually depict, this is also very easy to understand. But then I said, let's have both these things together. So this is the possible outcomes, and these are the sum of the outcomes. So the sum was not given here. So the sums are now given, and you can compute. So just imagine these are all the probabilities. The probability of 2 and 12 is the least. And then the next number which when you move up the probability line is 3 and 11. So the probability of getting a 3 or probability of getting a sum of 3 and 2 when you roll a dice, when you roll 2 dice, the probability of getting a sum of 3 or the probability of getting a sum of 11 is equal, because they are both happening only twice. So their probability is very low, and the highest probability is of getting a 7, and that is 1 by 36. So you have 1 by 36 chance of getting a 7. Probability is very simple. For example, if I say that, let me forget about the dice and everything. If I say that there are 10,000 lottery tickets and you buy a lottery ticket, you buy one lottery ticket. So when you buy one lottery ticket, what is your probability of winning the lottery? Your probability of winning the lottery is 1 by 10,000. The second thing is, if you buy two tickets, your probability increases because now you have got two tickets. So what is the probability of one ticket? 1 by 10,000. What is the probability of two tickets? 2 by 10,000. And what is the probability of 5,000 tickets? Half. And what is the probability of 50%? Or what if you have 7,500 tickets? What is the probability? 75%. If you have 9,000 tickets, what is the probability? 90%. So this is how probability is calculated. The only thing is understanding the concept of probability. So if you have let's say 9,000 tickets out of 10,000 lottery tickets. So what is the probability of winning? Your probability of winning is 90%. So what is the probability of losing? 10%, 1 minus 90. 100 minus 90 or 1 minus 0.9. So the probability is computed this way. So the probability could be written in a percentage, it could be written in decimals, or it could be written in fractions. So we will look at the example that we had taken in the class. So I'm just going to go there, and we will have a look at the example that we did in the class. It is the same thing we have been doing right now. But what we did was we made an Excel table. You see, probability you can do on a pen and paper. You can simply do it in your mind. You don't need a pen, Excel, or you don't need any scientific calculators unless and until you want to, you know, take it to some 10th, fifth decimal place or third decimal place, and so otherwise you can just simply write it in fractions. So let's talk of the first kind of probability is the simple probability that we have been discussing. Like for example, rolling a 5. So when we roll a die, what is the probability of getting a 5? It is 1 by 6. And 1 by 6 in decimal places is 0.16667. Okay, so I'll just make it like this. Now, the other classic scenario, like I said in the class, is about, you know, a pack of cards. So here we are saying what is the probability of drawing a king out of a pack of cards. So what is the probability of drawing a king out of a pack of cards? There are four kings. 4 divided by 52 is the probability, and which is equal to this. You can see 4 by 52 at the top. So this is 0.077. Okay, so that is the probability in decimals. So this is nothing difficult in understanding this. Then comes the rule of complement. The rule of complement, which I just explained a few minutes ago, that if you have 90% chances of winning, what are the chances of not winning? So 10%. So same thing here. So if the probability of picking a red ball is 35%, the probability of not picking a red ball is 65%. So 35, 1 minus 0.35 is 0.65, which is equivalent to 65%. Now, this is sum of two dice is not 7. This is just something which we had taken up a few minutes ago. So we know that the sum of getting, we know that the probability of getting 7 when we throw two dice is 1 by 6. So what is the probability of not getting a 7 is 1 minus 1 by 6, which is equal to this. So 1 minus, so actually and you can see it is 1 minus 1 by 6. You can see it comes here, the number is here. So we can simply understand this, that probability as a concept is very simple and very easy. It just needs a little bit of mathematics. So you can see 1 minus 1 by 6. Okay, so we will simply, you know, do away with this. Now let's come to the next part. What is the rule of sum and what is the rule of product? Not too much of rocket science is involved here. It's again very simple. When we are talking of rule of sum means when we are talking of more than one, it is actually a compound event. So we are saying we want to choose a Q or a K. Okay, when we want to choose a Q or a K, that means in a pack of card you have queens, you have kings, you have jack, you have aces. Okay, now when we are talking of a queen, what is the probability of getting a queen? The probability of getting a queen is what? 4 by 52. What is the probability of getting a king? It is again 4 by 52. Now we are saying it doesn't matter whether it's a king or it's a queen. As long as we get whether it could be a king, it could be a queen. It doesn't matter. If you just remember, just relate this. Now the numbers are more. So, don't get confused. We just saw the example of a few minutes back that coin flip. Okay, we saw that there were two coins which were flipped, and what were the possible outcomes? There were four possible outcomes. And we said, what is the probability of getting a head or a tail, or at least a head? We did the same thing here. So we added the probabilities up. So same thing here, we will add the probability of getting a queen, which is 4 by 52 plus 4 by 52. So if we go here, you can see this. This is actually the probability where we have added it up. So 4 by 52 plus 4 by 52 will be 8 by 52, and when you are to compute it, it's going to be the same thing. We can do it here if you want. uh, if I say it is equal to, if I put this is basically, just delete this and I say equal to uh, 8 by 52. So if this is equal to 8 by 52, what do we get here? It's the same thing. Okay, so let me just the number has come here, so let me just undo this. I don't want it to be pasted. So the number was the same. So it's actually, let me just do it here. It is 4 by 52 plus, we have a plus sign, and that is again 4 by 52. That is the probability of the king. 4 by 52. I hope Excel takes it without me putting the bracket. So it has given us the probability 153, which is the same as this. So I can just narrow it down to 3 decimal places and do the same thing here, and you can see. So it is 0.154, it is 0.15. So we are saying what is the probability of a Q or a queen. So in this, why are we taking a sum? It's very simple. Because now what happens, it is just like the old example that I had taken, one lottery ticket and two lottery tickets. So two lottery tickets, what? One lottery probability of one lottery ticket plus the probability of another lottery ticket. And they both have the same probability. In this case also, they both have the same probability. And we add the probabilities up. So here there are different cards and they have different probabilities. In that particular case, each lottery ticket had a probability of 1 by 10,000. So probability of two lottery tickets is more now because you have two lottery tickets. The same thing. Here the probability of getting another card is much more. So you are saying it could be a queen or it could be a head. It doesn't make any difference to me. Okay. I mean, I'm okay with both. Now, the third one, if you look at this one, next one, not the third one, the next one is slightly tricky. Tricky in the sense that calculating the probability is not tricky, but the way the question has been written, it could be a little bit tricky. What is the question here? It says that what is the probability of choosing a red or a king? Now, here we are talking of the probability of a king. So we have the probability of king as 4 by 52. What is the probability of getting a red card? Red cards are 26 in number. So that is the probability of red card is 26 by 52. So it is a king, it is a red card. Now what is the point to note here is that we have to exclude the probability because king is also red. So we can't take the probability twice. So we will have to exclude the probability. So you can see if you look at this formula, 26 by 52 is the probability. The first is the probability of getting a red card because red cards are 26 in number. Getting a king, the probability of getting a king is 4 by 52. But there are two black kings also. So we have to exclude the probability of those two black kings. So those are 2 by 52 and ultimately that is your answer. Okay. So this is actually 2 by 52. So this is your answer, right? Next comes your rule of product. Now in rule of product, we are saying what is the probability of rolling 4 ones in a row? So when we are throwing a dice, this is actually with the dice. So what we are saying is when we throw the dice, we should get a 4. So what is the probability of getting a 4? 1 by 6. Now we are saying we are throwing another dice, the second dice. What is the probability of getting a 4? It is again 1 by 6. What is the probability of throwing a dice the third time around? It is again 1 by 6. So probability is constant, but what is going to happen is we are going to multiply the probabilities because the event is going to become rarer, rarer and rarer. Because the first time we get a head or the first time we get a 4, is 1 by 6. The second time we get it, see, just try to understand this. Just try to understand this, and I'll just show you the example that we had taken, the throw of dice. Okay, so let me just go back. So here we can see how we have thrown the dice, and you can see. So what is the probability of getting a 4 and a 4? That means you get a 4 and a 4. So look at this. The probability of getting a 4 and a 4 is just this that you can see. You know, you can just simply see here. This is the probability. So you are getting 4 and 4 only once. In sequence, you get only once. So that means the probability of getting 4 and another 4 is 1 is what? It is 1 by 36. How did this 1 by 36 come about? It's very simple. In one dice it is 1 by 6. In the second dice again the probability is 1 by 6. So 1 by 6 multiplied by 1 by 6 is 1 by 36, which is the same here. So here there are 36 outcome, and 4 by 4 you only get once. So if you were to make this matrix for 4, what you will see is that you will only get this, the probability is going to, you know 1 by 6 multiplied by 1 by 6 multiplied by 1 by 6 multiplied by 1 by 6. So 1 by 6 into 1 by 6, that is 1 by 36 multiplied by 1 by 36. So that's going to be the probability of getting a 4. So this is, we just go back and I'll just remove this. So now once we are back, so we look at this probability, and what is this probability? 1 by 6 to the power 4. So because 1 by 6 into 1 by 6 into 1 by 6 into 1 by 6. So that is what you call as the rule of the product. When you want the same outcome, so how likely is that? Because see, it's a coin or it's a die. So when we are throwing a die, we can get a 1, we can get a 2, we can get a 3. But what we want is that we throw it the first time, we get a 4. The second time we throw it, we also get a 4. The third time we throw it, we also get a 4. And the fourth time that we throw it, we also get a 4. That means we don't want any other outcome, we want only these outcomes. So the probability is going to be multiplied in this case. So this is called as the rule of the product. So we want this 4 and a 4 and a 4 and a 4. So we say that whenever we talk of and, we always multiply. We say it's a rule of the product. We always multiply. And whenever we talk of this or that, a queen or a king, we are happy with both. So we always talk in terms of the rule of the sum. So that is how we talk of. So we add the probabilities when we are talking of or, we multiply the probabilities when we are talking of and. There's one more scenario which is here, which is about choosing a king and a king. So it's an and. So it's very simple. A king and a king. We know we want to get a king the first time around and the second time around. The same thing. So what happens? What is the probability of getting a king? 4 by 52. What is the probability of getting two kings simultaneously? The first is the king and the second is the king. 4 by 52 multiplied by 452. This is when we are talking of without replacement. There is, in probability, there is a concept of replacement. In certain cases, there can be a replacement. In certain cases, there cannot be any replacement. Like, for example, when we are throwing a coin, now in this case, you get a head and you get a tail, you can't remove a tail. So the coin will only have head, that is not a possibility. But in the case of without replacing, in the case of cards, in the case of marbles, that is a probability that when you draw a card, you don't put it back and you keep it with you. So when you don't put it back, what happens? The probability of that, the probability goes down, the cards become 51 now. And the probability of that particular card is going to change. So we are saying we want to draw a king and we want to draw another king. So the first time the probability of the king is going to be 4 by 52. But the next time the probability of the king is not going to be 4 by 52. It is going to be 3 by 51. Why? Because now there are only 3 kings left because we have not replaced the king and the cards are from 52, they have become 51. So we multiply these two things and we get the probability. So 4 by 52, as you can see, multiplied by, you can see this. So we are multiplying this by 3 by 51, so you can see it here. Okay, so 4 by 52 multiplied by 3 by 51. So this is what probability is all about. Probability is very simple, and so you just need to think in terms of very simple. You just need to think in terms of the possible outcomes. You need to think of chances. You need to think of percentages. If you can't think in terms of percentages, think in terms of fractions. But always remember the probability ranges from 0 to 1. 0 is, that means impossible event. 1 is certain event. Now, if we go back to our, flip of the coin or roll of the dice, I want to demonstrate something. When you look at this, when you look at this gives you all the possible outcomes or the sample space when two dice are rolled. If I ask you what is the probability of getting a 1? In this case, we know that if there is a single dice, there is a probability of getting a 1. But if there are two dices, the minimum number that you can get, the minimum sum that you will get is 2. Because the minimum in both the dices is 1 and 1. So that means the probability of getting a 1 is 0. So that means it's an impossible outcome. When you roll two dices, then that becomes an impossible outcome. Because we are talking of the sum of the two dices that are thrown. So the minimum is 2, so you will never ever get a 1. So that's an impossible event. If I were to say that, what is the possibility of getting a sum from 2 to 12? Any sum from 2 to 12. So that means the probability is 1. Why? Because yes, I am saying from 2 to 1. So when you roll a dice, the minimum sum would always be 2 and the maximum would be 12 and rest would be in between. So that means irrespective of which sum you get, it would always be between 2 and 12. So that ways you can say very confidently that this is a certain event. That means it is going to happen because the probability of that happening is 1. If I ask you what is the probability of getting a sum of 7? So the probability of getting a sum of 7 is 6 by 36. So that is 1 by 6, which is not an even chance, which is lesser. So that it's again unlikely, but not as unlikely as the rest of them. So amongst this, getting a sum of 7 is the highest probability. So that's what you have to think about. This was a question which was put up by some of the students. They were not very clear. So that's why I decided to make. Till now, we have been looking at examples of classical examples such as rolling a dice, flipping a coin, or drawing from a pack of cards. But we have learned a lesson in terms of what is simple probability, what is the rule of complement, the rule of sum, the rule of product. And based on this, we'll do some real world examples. So let's take an example. And in this example, we know that the example is about human beings having certain diseases. So it's about the probability of having a heart disease, just one disease, that is a heart disease, which is 20%. And the probability that a person has liver disease, only liver disease, is 30%. And sometimes a person may have both the diseases simultaneously. And we say that the probability of having both the heart disease and liver disease is 10%. Now, obviously, here it's about simple probabilities, and it's also about the probabilities where we will talk of either and or, rule of sum and rule of product. So we'll have a look, which we have discussed previously, but we'll have a look at those things, those concepts in a real world setting. So these are some of the questions which are listed as A, B, C, D, E, and we'll discuss these one by one in the coming slide. I have solved this, I've done this on Excel, but you can do it manually. You can do a pen and paper exercise. It's a very simple calculation. It's only addition, subtraction, and multiplication that is involved. So you do need Excel, but I've done it on Excel because I wanted to paste the solution here. So let us look at the first part. A person has either heart or liver disease. So what we have done is we have made a table, kind of table, where we have listed the probabilities for having a heart disease, which was 20%. Having heart and liver disease both, that was 10%, and having a liver disease which was 30%, which is zero point 0.3. Now the first question is that the person has either heart or liver. So this is what we call as the rule of or. When we talk of or, it is always the rule of sum. When we are and when it is and, it is always the rule of product. So when we are talking of either heart or liver, so how many we have the heart problem here? So this is zero point 0.2 T1. We have both heart and liver, so the probability of this will also be added T12, and probability of having a liver disease will also be added, so this becomes zero point 0.6, that is 60%. So the, like we have been saying all along, the total probability is going to be 1. Okay, so in this case, probability of this is 20%, probability of heart and liver is 10%, and the probability of having only liver disease is 30%. We add them up, it becomes 60% because we're talking of either heart or liver. So heart is present here, liver is present here, heart is present here, and liver is present here. So we have all these three, and the probability is going to be added up. Heart but not liver, it's very simple. So there's only one, which is the heart. So this is the heart. So it's going to come here, 0.2, that is 20%. So there's no calculation which is required here. If you look at the third one, a person has liver disease but not heart disease. It's again very simple. It's the same thing, liver but not heart. That means here, why are we excluding these probabilities and why we are listing? Because we are talking of only liver. So the only liver probability is 0.3, which comes here, because rest of them contain heart. This contains heart and liver both, but it contains heart and it contains heart. So we'll only look at the probability of liver. So it's 0.3. Now it talks of a person has exactly one of the two types of diseases. What does it mean? It means you need to have only one of the diseases. That means either you can have this heart disease or you can have a liver disease, but you cannot have both. So this plus this, probability of heart plus probability of liver, rule of sum. Okay. So probability of heart plus probability of liver, this becomes 0.05, which is 50%. Neither heart nor liver. So we are saying you don't have any disease. So I said the total probability is 1. So we have either heart or liver. So what will we apply here? The rule of the complement rule. So 1 minus zero point 0.6 is 0.4. So you can work it out both ways. Okay, you can work it out both ways. You can compute this or you can just subtract this from 1. So 0.6 subtracted from 1 will become 0.4. Now this was about using the complement rule. It was about using the rule of sum where we have or. Now in the next example that we have, it's a different example, and let's assume it's a real world example. So it says that in Vibro, not all employees have a PG degree. That is, most of the employees do not, or some of the employees do not have postgraduate degree. So that means they are graduate. Now, one thing I would like to tell you, in the Western countries, especially in the US, there's nothing like a postgraduate. So what we call as postgraduate, they call it as a graduate degree. So graduate program. So their MBA is a graduate program. In India, MBA is a postgraduate program. That was just a piece of information for all of you. So this year, around 40% of all employees are female and the rest are male. That means 60% are male. Among female employees, only 12% have prior work experience, and in case of male employees, around 9% of them have prior work experience. So based on the above information, we have to calculate the probability of a randomly chosen employee has a PG degree, a randomly chosen employee with a PG degree being male, okay, a randomly chosen employee with a PG degree being female, and this year which gender has the higher likelihood of having a PG degree. So we'll do it the same way like we have done in the previous example. We'll make an Excel table. You don't have to make an Excel table if you don't want to. You can do it on a pen or paper, but you can make a table like this. It makes things very simple. So first let us write down the probabilities. So for example, the probability for, or the percentage of males are 60.6, female are 0.4. Percentage which we have listed as P2 of male employees having a degree, postgraduate degree is 9%, which is 0.09. and for female it is 12%, which is 0.12. People tend to make mistake here, you know. I also made a mistake. So people tend to make a mistake here. Instead of, if it is 8%, sometimes you'll write, you know, zero point 0.8 only, and the probability will come out to be different. So just be very careful. If it is 9%, it has to be 0.09, not 9. Now, so here the question is, the first question, a randomly chosen employee has a postgraduate degree. Okay, so that's the first question. So random chosen employee has a postgraduate degree is, we'll have to look at the, we'll have to look at the proportion of employees having a postgraduate degree. So we will talk of what that is in a few minutes. Okay, we'll talk of that in a few minutes. We'll come back to this a after doing the rest of the problem. A randomly chosen employee with a PG degree being male. So what is the probability? We are talking of the rule of the product. It's and. It's, we are saying that it should be a male and it should, he should have a PG degree. So it is the rule of product, because there is an and involved, male and postgraduate. So what is the probability of male? 0.6. And what is the probability of having a PG degree? 0.09. And when it is a and, we'll apply the rule of product. So 0.6 multiplied by 0.09 is 0.054. Okay. Similarly, a random chosen employee with a PG degree being a female, the same logic applies here, the rule of product, because we are saying a female and a postgraduate. So zero point 0.4 into 0.12 is actually 0.048. Now, when you sum this up, this is basically, if you total it up, it becomes 0.102. So that is the percentage of people who will be having, probability of people, whether male or female, who will be having a postgraduate degree. So this answers the first question. A randomly chosen employee has a postgraduate. So what is the probability? It is actually 10.2% or 0.102. The last question, this year, which gender has a higher likelihood of having a postgraduate degree? So males having a postgraduate degree is 0.054, and females having a postgraduate degree is 0.048. And what is the total number? The total percentage is this. So what we are going to do is, if we want to calculate the percentages or the fractions, point z for males it's going to be 0.054 divided by 0.102, which comes out to 0.53, which is 53%, and for females it comes out to be 0.048 divided by 0.102, which comes out to 0.47. So who has the likelihood? You can have a look at it here itself and you can say that males have a higher likelihood. Okay, but if you want to convert this into percentages, this is how you convert into percentages. But otherwise, you can just look at this and say that the probability is more for males as compared to the probability for females. And when you divide it by this, you get the actual percentages, because this number is 102.102. That is why they have this 0.054 and this becomes 0.53. The only thing is, if this number would have been different, then these values, percentage values would have been different. So ultimately the percentage is dependent on the denominator in this case. So that's all. Thank you. So you can, if you get questions like these in the examination, midterm examination or the final examination, you need to be sure as to what you are going to be doing. Thank you.